Okay. So we are trying to understand what are all the different components with respect to the Hadoop ecosystem. We did see about the workflow, what are all the different components of Hadoop ecosystem in the previous topic. And we did see about the components such as receivers, H3s, Spark, and what really happens from the data within the ecosystem. It is flow starting from the data ingestion, processing, to the various workflow. Now, in this particular session, we will try to understand what is MapReduce. So we have been seeing this term that's being used from the start of the session because when we talk about big data, these are some of the terms which cannot be missed out. It is MapReduce, PatchSpark, PatchHive, HDX, so we'll try to understand in detail about what is this MapReduce. So it's a programming model for processing data in parallel. So as the name goes, map reduce. So map phase is where divide and conquer happens. Reduce phase is about aggregate and summarize. That's how you need to remember. Map is with respect to map and divide and conquer. Reduce space is where aggregate and summarize. So what do we do in the map phase? Divide and conquer, it takes a large task, breaks it into smaller pieces, and runs them in parallel across the cluster. For instance, counting words in thousands of separate documents. We take a large task, break it into smaller pieces, and run them in parallel across the cluster. Reduce phase is about aggregate and summarize. So you collect the answers from the map phase, combine them into a final result. For instance, we can talk about summing up all the word counts. So map phase, we count the words in thousands of separate documents. Here you sum up all the word counts. So aggregate and summarize. Collect the answers from the map phase, combine them into a final result. Oh, you got an idea about what is MapReduce, divide and conquer, aggregate and summarize. So with that MapReduce, let us also try to have an idea about what is yarn. That is yet another resource negotiator, the modern brain of the cluster. So it separates resource management from processing. It acts as the cluster's operating system, allowing different processing engines like MapReduce, Spark, etc. to run at the same time. So initially, MapReduce handled both processing and resource management. Yarn was a major evolution, decoupling these. This made the ecosystem much more flexible and powerful, allowing new tools like Apache Spark to run on the same Hadoop cluster. So let's get into this topic and have some detailed understanding about what is MapReduce. So when we say MapReduce, it's a tricky to understand initially. So we'll try to understand it with a simple example that's given here in the pictorial presentation. So let's assume we have a file that has some words and the file is divided into blocks in the Hadoop distributed file system, we have to count the number of occurrences of a word in the file. So we will go step by step to achieve the result using MapReduce functional. The whole process is illustrated in this diagram. So you can see input files which has different fruit names, that is apple, orange, mango, orange, grapes, plum, apple, plum, mango, apple, apple, plum. So each line passed to individual mapper instances. So you can see apple, orange, and mango in one, orange, grapes, and plum in one, apple, plum, mango, and apple, apple. So with each line being passed to individual mapper instances, you map the key value splitting. You number them, like apple one, orange one, mango one, orange one, grapes one, plum one, and you have apple one, plum one, mango one, and apple, and plum. So you try to sort and shuffle all this information. So you can see all the apple in one particular box, and grapes, and mango, and orange, and plum in one box. So you try to reduce the key value pairs. That is, apple is 4, grapes is 1, mango is 2, orange is 2, plum is 3. And you can see the final output. So you can see on the whole, there are three phases here: map phase, shuffle and sort phase, then reduce phase. So in the map phase, you try to map or filter. So we'll call that as mapping or filtering step. The mapper function is applied to each piece of the input data. It processes the data and emits intermediate key value pairs. So many mappers run in parallel on different machines. So mapper function applied to each piece of the input data, it will process the data and emit intermediate pairs. So they will run parallelly on different machines. So after the mapper phase, it's the shuffle and sort phase. The grouping step handled automatically by the framework. The framework collects all intermediate pairs from all mappers. It sorts and groups them by key. So the result is key and then a list of all values for that key. So as in the example, we try to list out the apple names and then the values for that particular fruit is given. Then after the shuffle and sort phase, we have the reduce phase, the aggregating or summarizing step. The reducer function is applied to each unique key and its list of values. It processes the list to produce a final and smaller output. So aggregating or summarizing step, it's applied to each unique key and its list of values. So you try to process the list to produce a final smaller output. So many reducers can also run in parallel, similar to the mappers that's running in parallel on different machines. So each block will be processed. Each line in the block will be sent as an input to the process. So this process is called as mapper. So mapper parses the line, gets the word and sets. That is the word and then the number, the value for each word. So in this example, the output of mapper for line apple, orange, mango will be apple 1, orange 1, mango 1. So all mappers will have key as word and value as 1, which is the value of that specific fruit. So the next phase is where the output of mapper, which has the same key, will be consolidated. So key with apple, orange, mango, and others will be consolidated and values will be appended as a list. So in this case, that is in this example, we have apple, and then the list 1, 1, 1, 1. So the grapes, the list is 1. And then the mango, the list is 1, 1, and so on. We put that in the specific greater than less than symbol, and you keep moving on like that. The key produced by mappers will be compared and sorted. This step is called shuffle and sort. The key and list of values will be sent to the next step in the sorted sequence of the key. The next phase will get key and then the list as input, and we'll just count the number of ones in the list and will set the count value as output. This step is called as reducer. For example, the output for the certain steps are given as follows. So apple, then the list 1, 1, 1, 1 will be apple, comma 4. This is the key and the value. So the key term is apple and the value is number 4. The same way, grapes, the list is 1. So it will be grapes, comma 1. Then we have mango, the list is 1, 1, which will be mango, and then 2, which is the key value pairs. The reducer output will be consolidated to a file, and that will be saved in the Hadoop distributed file system. So all this key value pairs. So why did MapReduce become so dominant? So let us see the three primary reasons. So the first being scalability. So it was built to scale horizontally. That is, if your job is slow, you just add more cheap servers. Then the second, and which is huge, is the fault tolerance. So in a cluster of thousands of machines, failures are a certainty. MapReduce was designed to expect and handle these failures automatically without crashing the entire job. So which is something great. So we are talking about plenty of machines and there is higher possibility of them failing. So MapReduce is able to manage such failures without crashing the job that's being done. So it finally simplified the life of a developer. So you can focus on your specific problem's logic without becoming an expert in distributed systems. So these are the primary reasons why MapReduce became so dominant. That is scalability, fault tolerance, and simplicity. So scalability, you need more processing power, just add more commodity to the cluster, that is cheap machines. So linearly scalable from few nodes to thousands of nodes. So build fault tolerance, that is the framework automatically handles these machine failures. So if a node running the mapper or reducer dies, Yarn simply reschedules the task on a healthy node. The job continues without. So that is yet another resource negotiation. And finally, it's extremely easier for developers. They only need to write the business logic for the map and reduce functions. So the complex parts like parallelization, data distribution, fault tolerance, load balancing, all these are handled automatically. So you can understand now the different advantages of MapReduce, that is scalability, fault tolerance, and simplicity for developers. So with that said, we also need to know what are all the problems, like the limitations or challenges with MapReduce. So high latency. So it may not be working for real-time or interactive analysis. So significant overhead in starting jobs, making it slow for small tasks. So verbosity and rigidity. That is, writing Java MapReduce code can be verbose, which cannot be easy. So the strict MapReduce pattern doesn't fit all problems well. For instance, iterative algorithm for machine learning. Then disk input output intensive. Mappers write their intermediate results to local disk and reduce to the disk. So the input output, this input output can be a major performance bottleneck when compared with other processing. Of course, uh, batch processing system meaning it's designed for massive long-running jobs, not for quick interactive queries. The startup time alone can be 30 seconds or more. The programming model, while simple in concept, can be rigid and require a lot of boilerplate code. So significantly, its reliance on writing data to disk between the map and review stages makes it much slower than modern alternatives that can work in memory. So in summary, MapReduce is a divide and conquer programming model for processing big data in parallel. The developer defines two functions, that is map, which is transform, and reduce, which is summarize. The framework handles all the hard work, that is, we can talk about parallelization, data distribution, and fault tolerance. The shuffle and sort phase is the magic that groups related data together. It is highly scalable and reliable, but best suited for batch processing. So it laid the foundation for modern data processing systems like Batch Spark. So MapReduce really made the team understand how exactly they can work on the logic instead of managing to work with the machine aspects like parallelization, load balance, and fault or scalability. So that paved the way for recent advancements with Spark. So with that said, let's try to solve this MCQ on what we have looked at, these two questions. So one is about what is the role of MapReduce in Hadoop? So what are the four options one has to be chosen? And then the second question, in the MapReduce programming model, the reduce phase is primarily responsible for which of the following tasks? I hope we are seeing contents related to these two MCQs. So we can work on the answer. Um, Let us try to discuss it now. 3 minutes from now, the time starts. So 2 minutes is done. Around the 1 more minute to go. So almost time. Okay. So let us start the discussion. So what is the role of MapReduce in Hadoop? So we have seen about what is MapReduce and how exactly it's working in the environment. So the options given here is to understand the role. One is to manage the storage of data in HDFS, to provide a framework for parallel data processing, to handle data security and access control, to visualize and analyze processed data. The first one being about storage, the second one is about the framework, the third one is about data security, the fourth one is about visualizing and analyzing. The right answer is to provide a framework for parallel data processing. That is the right answer, which is the role of MapReduce. It's not about the storage or data security or visualization. Yep. So let's move on to the next question. So in the MapReduce programming model, the reduced phase is primarily responsible for which of the following tasks? That is, we know there are three different phases. So the map phase, shuffle and sort phase, and reduced phase. So we need to identify out of the four options which refers to the tasks for the reduced phase. Whether it's partitioning the data across nodes, sorting and grouping intermediate data by key, mapping the input data into key value pairs, filtering the data based on specific criteria. So the right answer is sorting and grouping intermediate data by key. Because the reduced phase is the final phase which has to make sure to sort and group the intermediate data with the key as the sorting function. So it cannot be partitioning data or mapping the input data or filtering the input. It cannot be. So the right answer is sorting and grouping intermediate data by key. And for the first question about the role of MapReduce, it's to provide a framework for parallel data processing. Okay. So the next is the descriptive questions. So these are some possible descriptive questions you may get of this particular topic. So the first question is explain why MapReduce is a massive parallel processing framework. The second question is describe the basic architecture and flow of a MapReduce job. You just take some time and you can solve these two questions and try to make some notes of these two questions so that if you discuss, you'll be able to understand which is right and to what extent you need to add some more information. So let us take 5 minutes of time so that we're able to have at least 2.5 minutes for listing out some key points for each questions. So the time starts. It's almost time for first question. It's going to be 2.5 minutes. Still have only 2.5 minutes for the other questions. So just try to write some key points. Why map produces a massive family process framework. Then we can proceed towards the basic architecture and flow of the history. It's almost time. We still have another 1 minute. So I hope you're done with the first question about MapReduce. Because the reason we read MapReduce being massive file processing framework, and I hope you have started to work on the basic architecture and flow of this job. We'll take another 30 seconds and then we'll start discussing the key points for these two questions. Start the discussion with the first question. Explain why MapReduce is a massive parallel processing framework. So for this, you will have to write about MapReduce being able to process faster, scalable, and fault-tolerant data of a distributed environment. So similar to HDFS, MapReduce can also be executed even in commodity hardware. It assumes that nodes can fail anytime and still process the job. So massive parallel processing framework, faster, scalable, and fault tolerant distributed. So all nodes can fail anytime. Any node can fail anytime, and still it will be in a position to process the job. So it can process large volume of data in parallel by dividing a task into independent subtasks. So MapReduce also has a master slave architecture. The input and output, even the intermediary output in a MapReduce job, are in the form of a key value pair. Key and value have to be serializable and do not use the Java serializable package, but have an interface which has to be implemented and which can be efficiently serialized. As the data process has to move from one node to another, key has to be a class that implements a writable, uh, comparable interface. Sorting the key and value has to be a class that implements that implementation. So your answer should make sure to reason why MapReduce is a massive parallel processing framework for its faster, scalable, fault-tolerant feature. How exactly the input and output intermediary output are form of key value pairs. So the second question is describe the basic architecture and flow of a MapReduce job. So we need to first detail why or what is this MapReduce. So it's a programming model designed for processing large data sets in parallel across a cluster of computers, consists of two main phases. So map and reduce input splitting. The input data is split into chunks called input splits. These splits are distributed across the cluster nodes. So basic architecture about what is MapReduce, input splitting, map tasks. Each map task processes the single input split. The output of a map task is a set of key value pairs. Shuffle and sort the intermediate key value pairs are shuffled and sorted based on the keys. This ensures that all values with the same key are grouped together. So intermediate key value pairs are shuffled and sorted based on the keys. This ensures that all values with the same key are grouped together. Then the final phase, which is the reduced tasks, each reduced task processes a group of key value pairs with the same key. The reduced task combines these values into a single output value. So the reduced task process a group of key value pairs. The reduced task combines these values into a single output value. So the final output of the reduced task is returned to the output destination. So these are the answers for these two questions. One is about why MapReduce being a massive parallel framework. The other question is about describing the basic architecture and flow of a MapReduce job, the significance of shuffle, insert, reduce task and map tasks. So with that, we come to the end of this particular session wherein we did discuss about what is this MapReduce all about. We did see an example to prove about how exactly these three phases really work, that is starting from mapping phase, shuffle and sort phase, and then reducer phase, and what will be the output that we get. So the fruit available in different lines, we try to put them in proper order, and we understood how exactly this key value pairs work in this map of this job. How significant is this? What are all the benefits of using this map of this job? It's being scalable in other features as well. So, for additional information on this particular topic, you can refer the book titled Big Data Analytics. It's published by Wiley Publication back in 2020. Appreciate your patience in listening to this video content about this MapReduce. Thank you. Appreciate your patience. In the upcoming video, we'll try to look about more in detail on the other components of the ecosystem. Thank you.